So 71 type 3, you will see that I use a lot of concepts you've already learned to just let you see a pattern here and how to do it, okay? So this is a scenario where you are provided with 2 points and you have to find the third point. And the key here is using symmetry. That is unique to a quadratic, okay? That it's symmetric. So that's the key here. And the symmetry always has to, it revolves around the vertex. Revolves around the vertex, okay? So the best way to solve this type is to sketch it first. Strongly suggest you to sketch it first. Doesn't have to be to scale, right? And then remember that the third point is across the starting point. There's most definitely going to be a third point across where you start. So let's say you have a scenario. The left side revolves around on the ground, and this would be off the ground, right? So 2 different scenarios. And in this particular case, the vertex is given. So that's something I need you to highlight with a different color. So the vertex is given. So let's say this scenario here, a ball is kicked and reaches a maximum height of 17 feet after 1.25 seconds. If you at all see maximum or minimum, that is indicating that that is the vertex, okay? Clearly. So where does that go? That goes at the highest point here. And don't be thinking it's always going to go like this. It could go this way, right? The parabola could go this way, but that's the most common. So this will be 17. Don't mix that up. Time always comes first, then height second. And what's our starting point? If it's on the ground, 0, 0, right? Don't forget about 0, 0. It's very helpful. And the key here is to find this point right here. Please grab a highlighter or a pen or something and make sure you go to the vertex, right? And you're saying this is the symmetry here. This is the line of symmetry, the axis of symmetry, okay? And then we're gonna make that conclusion that how many units did it take to come from here to here? 1.25, correct? So it stands to reason that to get across, right across from the other point that you started is going to be another 1.25, correct? So it's going to be 2 times 1.25. So this point right here is 2.50, 0. That's the third point that you needed to find. And quite often, the easiest way to do it is just take the x value of the vertex and just multiply it by 2. You get that. So what if it's off the ground? So an object is thrown from a height of 8 meters, reaches a maximum height, there's your vertex again, reaches a maximum height of 13 meters at a distance of 3.5 meters. Distance is the horizontal move, so that means that this is going to be 3.5 and this is going to be 13. So there's your vertex. What's this point going to be? 0, that's my y-intercept, right? 0, 8, right? There's the y-intercept right there, 0, 8. And now, grab your highlighter and draw your axis of symmetry. Green isn't a really good choice, but I think you can see that. And now, here we go. You start at your starting point. How many units to go from here to the axis of symmetry? 3.5, right? So it's going to take you another 3.5 to get to the other side. So the coordinates of this new point would be 7, 8. Not 7, 0, right? Why is this 8? Because it's right across where I started. I started at 8, So this gets, right, reaches the maximum height, comes back to 8 at that point. And notice this. This object does hit the ground, it seems. Okay? But we don't know this coordinate. We can't. We have to stay within this little cap here using the axis of symmetry. Okay? So in a sense, you went times 2 here to get the 7. Okay? So at this point, obviously, and you've done this already, we've done an AC on this, you could go a time and height here, and you just type in those points. I would really encourage you to do a table like this, because if you don't, sometimes you flip the numbers and you don't get that right. Over here would be distance and height. You start at 0.8, then it's 3.513, that's the maximum, and then it's 7, sorry, it's just 7 there, and then 8 on here. So you kind of tell that you start at the height and you end at that height when it comes to the point generation. You just have to know why are we doing this? It's just to come up with the model of this curve, that's all. Once you have 3, you get to make a regression, come up with a thing that's going to tell you everything about that curve at any time, right? So that's why we're doing this. So don't be thinking, wait a minute, this hit the ground, I have to know this point. Not right away. At first we just deal with the axis of symmetry. So this is the AOS, right? This is the AOS. Okay. So there we go. Let's go and do a couple more here. Let's see if we could do that. Well, I'll do this one because in this case the vertex is not provided, not fully. It's not fully there. Okay, so vertex is not provided. So I'm going to just circle that. An object is thrown upwards, reaches a maximum height of 40 feet, and lands and remains airborne for 8 seconds. Remains airborne for... So this point right here, based on this context, we're assuming we're starting right on the ground. This gets the projectile, the object is reaching the maximum height, which we know is 40, correct? But we don't know the time just yet. We don't know how long it took to get there. Do we know this point in this case? It's 8-0, yes. So in this case, this question tells you the whole flying time, right? The air time, which is right there. So, axis of symmetry again. That's why we talked about the axis of symmetry all this time. So what will we do here? We do reverse thinking. If it took 8 to get from here all the way to there, it'll take half the time to get to the center. So we're going to divide by 2. That's it. You just have to read carefully. What am I given here? And so in this case, that'd be 440, and voila, you've got your 3 points, and you can type them in and get your equation that way. So time height, 0, 0, 440, and 80. And there you go. So the third point in this case that needed to be generated was actually the vertex. And by that I mean just the x value of the vertex in particular. And here it is, the one that's facing up. A skier goes down a 30-foot ramp. The lowest height it ever reaches is 12 feet and reaches the initial height at a distance of 50 feet. Come up with the equation. We're told that the ramp is 0.30, right? We're starting at a 30-foot ramp. Then we reach the lowest height, which is 12. This is not a very good, I'm just going to go 12 here. And we don't know the distance just yet. That's a question mark. Then we reach the initial height of 30 again at a distance of 50 feet. So we're told that right? The distance is 50 feet, and we have that same height that we started with. So that's why there's a 30. So that's the pattern here. And again, axis of symmetry. So that just keeps on going to infinity there. Doesn't matter. So if it takes 50 to get right from the start to that point across, it will take 25. We divide it by 2. It'll take 25. In this case, the distance will be 25 to get to the lowest point. And then there you go. So technically, if you wanted to think of it this way, you now know it's 25 and 25, right? You split that distance in half. Same here, if you care to do this, this is 4, and this is another 4. So you should be able to observe that pattern. So this would be distance and height, 0, 30, 25, 12, and 50, 30. There we go. So now we will actually do an example, a word problem. What does it look like? And the emphasis today is just coming up with the 3 points and the equation. Everything else, technically, you already know how to do. It's all second trace something, right? That's what it's all about. So let's go to 72 here. And to break this down a little bit, I want you to read this and make a very small sketch here. I want you to sketch, and I want you to try to find 3 points on this graph. That's it. Just label 3 points and the coordinates and see if you can find that yourselves just by reading this. So give this a minute or two. All right, let's see here. So Roger would like to recycle his beverage container. He throws his container up from a height of 1.75 meters and estimates that it reaches a maximum height. There it is. That's important. That is your vertex. Reaches a maximum height of 2.8 meters after 0.75 seconds. So that's important. The container lands on the rim of the recycling bin, which is 0.65 meters tall. So it doesn't hit the ground, right? That's something to remember here. So let's imagine we are at 1.75 right here. So that point right there is where it all starts. 1.75. It gets thrown up, reaches the maximum, and then it lands on the rim of the bin, which is, if this is 1.75, 0.65 is somewhere here, right? It's just a rough sketch, right? This is the bin. All right, so we don't know how long it will take, but we know that that bin is 0.65 meters above ground. And we do know the top here. This is what? 0.75, 2.8. Okay, it's important not to mix this up. Time, I have time here. I've got height there. This is just a sketch. Okay, this is all about the axis of symmetry, remember. I want you to remember that. So if we start here and we get to the center, it takes how many seconds? 0.75, right? How many seconds will it take to get from the center across to this point right here? Another 0.75, yeah. What height are we going to be at if we're right across where we started? 1.75. Yeah. And this will just be 1.5, right? It's very crowded here. I need to make more space for this question here. Times 2 to get the 1.5. Do you have 3 points at this time? What about this one? It's there. It will probably come back. Okay? So too much information at this point. Don't worry about this one. Just focus on the axis of symmetry and focus on finding 3 points around the axis of symmetry. Got it? So let's come up with our table. Time and height. Folks, this could touch the ground. It could have told you to touch the ground. If this touches the ground, what's our height here? 0, right? But we don't know how long it takes. So it's also too much information. So there will probably be too much information at times. You just have to focus on the axis of symmetry here. So here we go. 0, 1.75. Then it's 0.75, 2.8. Then it's 1.5 or 1.50 back to 1.75. And we go L1, L2, okay? And then we go stat, calc, quadratic regression. Remember, it all has to do with the axis of symmetry. Let's come up with our, let's go about this problem. I'm clearing everything. I'm going 0, 0.75, 1.5. 1.75, 2.8, 1.75. There we go. I'm pretty sure I already did quadratic regression at one point. I'm just going to copy paste. And there it is. I'm just going to verify. Yeah. So y is negative 1.87 x squared plus 2.8x plus 1.75. That is what this question wanted, and this would have been a 2-mark question. If you see 2 marks, it means I need to see some way that you came up with the points and another point for the actual equation in this case. All right, so now we can answer anything. We have the equation. How long does it take for the beverage container to reach the rim of the recycling bin? It's asking for this point right here. Like the rim is right there. I will make another sketch here. It reaches the rim right there. So it's asking how long will it take to reach the rim of the recycling bin. What do we do to solve that? Y2 is 0.65. Second, trace, intersect. The only problem is we need to make sure we see this graph on our screen. So let's go ahead and hit graph. Okay, this could happen to anyone. So what would I do here? I'm going to hit enter, just quit this. My guess is, remember I had plot 2 turned on? Which one do you want on? Plot 1, right? So that's probably what it is. And it's not a good graph. I'm going to try zoom 9. And there you have your 3 points. But I want to see more. Remember, it's not a perfect zoom. X min, I'm going to make that -1. And Y min, I'm going to make that -1 or 2 or something like that. -1 will probably do here. That's much better. And I also want to see more on the right side. Remember, we don't care about this tail here. X max would be 3, let's say. That's a pretty good graph right there. Now I can go about solving this. Y2 is 0.65, graph it. Second trace 5, find it. 1.82 seconds. Okay, that's how long it would take to reach this point. I want you to state the domain and range here. by yourselves right now, with the information that we have, and we know that this stops at the rim, what would be your domain and range in this situation? This is always going to be 2 marks, okay? So if you get that wrong, you lose potentially 2 marks if you don't know what you're doing. So based on this information, give me the domain and range. Domain is time, range is height. Try it. Even if it's wrong, there's lots of space to redo it. In terms of domain, 0 to 1.82. In terms of range, never hits the ground, correct? What's the lowest height this ever reaches? 0.65. And the highest is your vertex, right? 2.8. So the domain and range is it's basically telling you what the graph should, should it start, where should it stop, in terms of the x's and the y's. How long does a container remain below 2.5 meters? Let's change this for today, because I'm just going to say how long does a container remain above 2.5 meters. What do you do in a question like that? Do you remember? You need to know this. Y2 is 2.5. Second, trace, intersect. And in this case, you want to graph your 2.5 line and find these 2 times here. And what are we going to do with those? We're going to subtract them, because you're asking how long did it stay at or above. So the first one is 0.3491. The second one is 1.1509. Delta T 1.1509 minus 0.3491, and that gives you 0.81, sorry, 0.80 seconds. All right, I'm going to just say, if you want to try, it's 73 and on. 73 to 76. And the graph, the reason I'm not doing the graph is because I will post the key to that. So if you want to go, but it would be the same as always. A scale, right? Have the intersects, have the vertex, have all of that ready for that, okay? So I will include up until this point on the quiz. Okay, there'll be one question on this kind of stuff tomorrow. I will, and then remember your quadratic formula. Remember how to graph, how to sketch a quadratic without a word problem. Then it's all 4 quadrants, remember that? So just go through your booklets and know how to do it, but it's going to be heavier on word problems. There's going to be maybe a little bit on graphing, something that doesn't have a context, and then it's all word problems.